Oh. Check. 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 Huh. Can you guys hear me? Can someone in the chat confirm if you can hear me or not? Okie dokie. I think we're good to go. I accidentally stopped and started the stream thinking I didn't have the thing on. Oh man, we have someone from Arizona. Boy, oh boy. This is going to be good. All right, let me pull this up. Looks like that's working. Okay, gonna give you a second here. Open this up in another local host. And then let me bring this back in. All right, cool. It sounds like the stream's going well. Everything looks to be working. Nice to see some people from some swing states given today's topic. Not going to get too political in today's topic, but what we will be covering is kind of an event that happened on election night. So in case you haven't already, go ahead and, let me paste this in, whoops. Go to this link. So in case you haven't already, download the code here. Green code button at the top right. Let's see, download. That is it. And just so you're aware of, there's typically a strong delay, and it gets worse and worse as time goes on. So, like, I think you guys are right now about 1 or 2 minutes behind what I'm actually saying. So, if you type a question, let's see, yeah, you're maybe a full minute and a half behind me. So just keep that in mind. If you type a question in response to something you see in the video, I'll respond like a minute and a half later. And the delay gets further and further along as we keep recording, just to let you know. All right, so we have this public repository. It has some CSV files for you on some election data, and then it contains some funny JPEGs just to give you a hint of what we're doing. And I'm going to quickly go over what the plan is for today. And this is kind of more of a data analysis. And we're not really going to answer the question directly. We're going to leave it up to you, the user, to decide. But essentially what happened, in case you weren't keeping up on election night, basically, Fox News was one of the first people or media outlets to call Arizona for Biden. And they actually did it at 11:20 p.m. Eastern time on election night. So in case you weren't really paying attention to the US election, that was pretty early. And so what we really want to answer is, was that unreasonably early? Can the math work out where we could see a very clear path where it was kind of inevitable for Biden to win? Depending on how closely you were watching this, you would have known that other outlets like New York Times or Associated Press, they didn't call Arizona until like past the 7th or something like that. So they waited days after Fox News called Arizona. So just keep that in mind. Really what we're trying to answer is, can we see the math actually work out? Did they call it too early or not? And we'll see that it may have been even too early to call it on something like November 7th, just because it's still unclear where the data is. Okay. Any questions so far? If you do have any questions, let me know. If the audio is cutting out, I'm just going to say, if audio or video is cutting out, you may want to slightly rewind 2 minutes back. There we go. Okay, so what we're going to be doing is we're first going to be showing you kind of how to plot out a county electoral map. In general, we got requested a lot, and I think we did this a tiny bit in the COVID data, but we'll really get into it on this stream. This is not how the electoral map went, by the way. So what we're going to be doing is we'll read in some JSON data, and we'll talk about how Plotly can work. And we'll first start off by just exploring how to plot basic counties with some, I think it's unemployment data. And then we'll kind of show you the customizations to the argument calls. Then we'll look up some New York Times election data, and we'll be working with November 7th election data. Unfortunately, I couldn't really find anything nice on November 4th election night, but maybe you guys can search the internet for it. And it should be easy to kind of replace it in there. And then we'll move on to understanding certain columns. And then we'll also be creating some more plots in terms of win percentage. We'll keep making some more maps until eventually at the end, what we kind of want to do is a little interactive slider. You won't see it right now, but it will let us slide, and we'll create a little function here that says we expect Trump or Biden to win this many percentage votes coming in. And so like, will that be enough to win? Okay, and then we'll put it all together and we'll have some final thoughts. Okay, and for the people in Glasgow or UK watching. So let's get started. I'm going to close this one and kind of start fresh here. As a quick note, you will need to install Plotly for this, which you can do with a pip install Plotly, or I think you should even be able to conda install Plotly. So I'm going to shut down this guy and start a new notebook. And if you have any questions as we go along, probably the best way to do it is just type them in. Well, obviously you can only type them in, but I will reply back with a type, since that's instant communication instead of the delay. Since I see you guys are kind of, let's see, you're maybe about, actually I don't know how delayed you are now. Quite delayed, I assume. Okay, let's take a look at this. I'm gonna type, "Hey, good to go. Everyone has been All right. I'm gonna go ahead and start typing, and if anything happens, you can just go ahead and let me know. Okay, trying to see where I am on the stream right now, on the live stream. Looks like we're about 7 minutes in. Okay. So yeah, about a minute and a half behind. All right, let's see what happens. Okay, cool. All right, that should work out for us. So let's start with a couple of imports. We're going to need to import JSON since that's the format the data is in. And I'm also going to import NumPy as NP and import pandas as PD. Okay. So the first thing when we're talking about geographical plotting is we have to figure out how the format of the plotting needs to actually occur. And this is super dependent on what you're actually trying to plot. Certain libraries are pretty much like ready to go right out of the box on things like United States county plots. But if then you try to do something like Mexican states or something like that, the library has just no support. So really, at the end of the day, what you need to do is figure out, do I have the correct JSON file for this, and does the plotting library support it? The United States is probably the most supported out of all the libraries just because that's the way it is. But you may need to do some more customized research in case you want to plot out a different country. That's not something I kind of know off the top of my head. But what we did is, if you check out Plotly counties, there is the United States county choropleth, which essentially is just going to shade in or fill in. And so what we're going to do is, I recommend the GeoJSON. So there's essentially these GeoJSON files that are part of this zip file you just downloaded. And what we're going to do is we're going to create these plots. And the way it works is there's essentially this FIPS or federal ID. And every county in the United States has a federal ID code. You can almost think of this as a zip code, right? And you can see we have this code and then some attached number to it. And what we're going to do is we're just going to figure out how can we plot a data set like this on top of a map so that it looks like this. And then once we have that, we should be able to start putting in information based off counties. Okay. So what we're going to do here is come back and we're going to open up that JSON file. If you take a look, there is a GeoJSON counties fips.json. You can open it up to check it out, but it's essentially just a bunch of geographical information for each county, essentially kind of telling you how to outline that county. You'll see it has the county ID, which is kind of like a zip code basically, and then points of where to draw the polygon. So that's what this JSON file is. It's essentially an ID and then draw this polygon with these coordinates. And obviously the more complex the county, the more coordinates it's going to have. So let's close this and we need to open that up. So we're going to say different ways we can do this, but we essentially just need to read in as a JSON file, which is why I loaded JSON here. We'll say with open, and it's called GeoJSON counties fips.json as response, or really you can technically call this label whatever you want. I'm going to say counties is equal to JSON.load response. Okay, so the JSON library in Python just allows you to read in JSON. And so if you check the type of counties now, it's no longer JSON, it's a dictionary. And if you're familiar with JSON, it's basically going to look a lot like a dictionary. So when we read it into Python, Python basically converts it internally as a dictionary, which means it actually has keys. And it has the type and features, which we kind of just explored. It was the polygons and the fips. So then the next thing we're going to do is we're also going to load up the data frame. And the data frame is the one from this. We're going to basically go through a quick example of how to plot everything. So we have this data frame that has this federal ID code that FIPS that goes per county, and then some employment number. And that's the main idea behind geographical plotting. You have some identity for the geographical region, and the GeoJSON has the polygon that plots that out. And then we have some number I want to attach to it, and I'm going to shade based off that number. And then from there, you can do whatever you want with that number, or filter down by certain counties, etc. So I'm going to say df is equal to pd read CSV FIPS, and this one's called FIPS unemployment, and it's the unemployment data from 2016. And the one thing we have to note here, and this is kind of a special case for the counties, you'll notice that FIPS actually has a leading 0. So if you were to zoom in here, you'll notice the very first FIPS have a leading 0. If you read this in by default in pandas, it's actually going to delete that 0 and read it in as a number because it thinks, oh, a leading 0, it doesn't need that. So to make sure that doesn't happen when you read it in, you have to say data type, comma, data type is equal to, and we're going to say FIPS string. So we need to make sure we read in that FIPS as a string from the very beginning to not remove that leading 0. Otherwise, we get errors. Technically, you don't get errors. You just get a bunch of missing counties. Okay. So in case you want more detail on what FIPS is, it's the Federal Information Processing System code for states and counties. And we have a link for you in the notebook that you can go check out. It basically takes you to the USDA government page on the FIPS and the state that it belongs to. So people in the United States can figure out what that is. But for us, we don't really need to know about that too much. What we're going to do is import plotly.express as px. And plotly express is essentially Plotly's way of just quickly plotting out geographical things, or really plotting out anything quickly as kind of these large one-liners. The trade-off is, even though it's one line, it must be like 10 to 15 arguments sometimes in that one line. So it's technically a one-line code call, but you're passing in like tons and tons of arguments. Whether or not that's kind of smoother than older Plotly is up to the user. Okay, so let's create a figure. And we're going to call px dot choropleth mapbox. And then for the choropleth mapbox, what we're going to do here is we have to tell it where's the data frame of data that matches up the FIPS to some data point, so df. And then we need to tell it the GeoJSON data. And recall, that's the counties we just read in up here. And then the last thing we're going to do is set up the locations and map style. So we're going to say locations. And locations is what tells choropleth mapbox. It's a string code and tells it, hey, what am I actually plotting here? And so for US counties, the default string is FIPS. And this is why you kind of have to look up in the documentation to see if your string code for whatever you want to map is actually supported here. So then what we're going to do here is then say Mapbox Style, and the default style is just choose Carto position. Okay, or whoops, positron, not position. Carto positron. There we go. It basically is the like default Mapbox style. So once you have those 4 arguments, you have your data, you have your geographical county polygons, you have this locations equals FIPS, which makes them understand how to connect these two, since they both have FIPS defined. And then we have some default Mapbox style to choose of what we are actually plotting on top of. And then after this, you're going to say fig.show. Run that, and eventually you should see the figure show up. Keep in mind, these figures can take up a lot of memory, just a ton of RAM, so you probably want to clear the output of the cell instead of having them all open. So as we edit these figures, just keep closing them down, or keep editing the same figure cell. You should get something that looks like this, which is a gray weird map or block, and what you want to do is actually, with your mouse wheel, scroll out, so essentially zoom out here, and eventually you realize that it actually centers you in the middle of the map, which is essentially the middle of the ocean, which is why we didn't see anything at first. So you have to keep zooming out, and it'll keep filling it in until eventually you'll begin to see the United States, and boom, there we have it. So what we have here in the United States is the geographic filling out of all these counties. So it creates all these polygons for us on top of these maps. You'll notice, for whatever reason, we're missing like a few counties. We're missing one here, and I think there's one like somewhere in the south that we're missing as well. But you now have a general idea of what we can plot, and now what we want to do is figure out how do we start connecting things like the data, the unemployment data. So what we'll do here is we'll start editing the options that we have inside of this. And then what I'm going to do here is say, okay, so step 1 was to just plot out all the counties. We're there. That's good. But recall that if I actually take a look at what DF represents, so I take a look at DF head here, it's the FIPS and the unemployment. What I would really like is to actually color this in by that unemployment number. So while we now know the very basics of plotting out the polygons, what we haven't really gotten is any information off this data frame. So how do we do that? Well, what we're going to do here is we have to actually tell it what the labels are going to be. So we pass in our data frames DF, GeoJSON counties, locations, and then for color, you'll notice we have a column called UNEMP, that's unemployment. We have to actually tell it what should the color be based off. So we say color is equal to UNEMP, so it matches right here, unemployment. And you should be able to just rerun this again, and let's see if this works for us. This should automatically create a color scale for you. There we go. There's the color scale. Notice again, it's starting in the middle of the ocean, so you have to zoom out. And we'll tell you in just a second how to center it. But you can see now we are having a color scale based off unemployment. And we'll be able to kind of edit this color scale and do more of it. But now, that's all we had to do to connect it to a data point. You just say color it by, and then the name of the column inside this data frame. So other things we can do, it's kind of annoying to keep centering it in the middle of the ocean, right? So what we'll say here is center it. And as I mentioned, you know, it's kind of annoying that this is technically a one-line piece of code, but it's just argument after argument. So center is a dictionary. It takes a latitude and longitude. So you say latitude, colon, the value you want, and then LON for longitude, colon, the value you want. And I'm just going to copy these from the notes where we say latitude of 37-ish and longitude of -95. If I run, and let's actually add one more thing in here. Let's add in a color range. So we can say color continuous scale is equal to, and with a capital V, Viridis. And pretty much all of these you have to look up in the documentation. So while I was developing this notebook, I had the documentation open on another screen because there's just no way I had all these arguments memorized, or even the weird like Plotly things where this V has to be capitalized. So there's a bunch of weird stuff like that where I would recommend if you're ever doing this with Plotly, you just have the Plotly documentation open right next to you. So we'll go ahead and run that, and we'll see if we were able to center it and also change the color scale. Okay, so we were able to center it. However, we're still really zoomed in, so we should affect the zoom as well. And now we have this different color scale as well. And what we're going to do is probably make the color range not as extreme from dark to this super light, just because the color overall is being a little distorted by some areas where the unemployment is just super high. It's kind of crazy. It's like 23% unemployment over here. But what we're going to do is to fix the zoom, we add in a new argument, and just careful with your commas here. It's really easy to forget them. We'll say a zoom level of zoom is equal to 2. That will zoom us out a little more. And then you'll notice these are completely dark or opaque. What we can also do is say opacity, almost like an alpha value, is equal to 0.5. Let me say, any questions so far? I think I'm about, let's see, let me check my timer. 22 versus, all right, I'm about like 5 minutes in the future now, or 6 minutes. So just keep that in mind. By the time you see this, you might be like 10 minutes behind. Sorry, it's just the nature of the streaming, I guess. Okay, so I'm gonna add a little bit of opacity because there's actually map information. There's like cities and stuff underneath this. So I'm gonna add it a little bit of opacity, and I think that's mainly it. Oh, and the color range was the other thing. So I'll say range color goes from, range underscore color goes from, let's say 0 to 12, just so it's not as extreme. This is something you can definitely play around with. And again, watch out for your commas here. I'm gonna run this one more time. It's gonna load up a little bit. And now we have something that looks pretty nice, I think. It's a little more opaque, which means I can actually zoom in here, and I can see the cities and areas where the unemployment happens to be. So you can see right here, I'm not even sure how many people live here, but very close to the border. And it's also now the color range is not as extreme because I kind of lower the range. of the values to go from 0 to 12. And keep in mind, these values 0 to 12, what they're referring to are the values here. So now essentially, anyone that has an unemployment rate over 12 is going to be colored the same. So even though this guy has an extreme unemployment of like 23.5, someone that may not be so extreme, like let's say this one's also pretty yellow, of 11.9, you can see they're almost the same shade of yellow, even though this one's like almost double the unemployment. So that's what happens when we change that range color. So just keep that in mind. Okay, so that's pretty much it for the very basics of plotting geographical data. If you have any questions, feel free to put them in the chat and I will type out a response instantaneously. But what we're going to do now is move on to reading in the election data sets. And this is kind of hard to find. Apparently you have to pay a lot of money for some of these data sets. So there was a lot of GitHub repositories that were actually scraping this data off of the New York Times. So if you ever visited the New York Times during election night, you would have seen they had like their county data ready to go, and people were scraping that during the whole night. Excuse me. And so what I did was I kind of just got those CSV files. We have one for November 7th and one for November 18th. Unfortunately, as much as I could try, I could not find one of somebody that had scraped the same information for something earlier than November 7th, just because, you know, it was still unknown at the time who won on November 3rd. So if you can find that, you should be able to replace it, but hopefully we'll see what happens. Okie dokes. So what we're going to do now is let's go ahead and read in this data set. I'm going to clear this output, so say cell clear output, and I would encourage you to do the same because that just takes up a lot of memory to have that thing open. We'll say presidential November 07 is equal to PD read CSV. And then we're going to read in the results. President November 7th. And same as before, we have to say the data type is equal to FIPS. And it's going to be as a string. And if we take a look at the head of this data frame, you notice we have FIPS, which is pretty much exactly what we need, and we have a bunch of useful information. We have the votes, absentee votes, reporting, precincts, and there's 106 columns. We definitely don't need all of them because it's actually keeping track of a lot more information than what we need. You'll notice it's keeping the results for a lot of candidates that we don't really care about. We really only care about the two main contenders, Biden and Trump. And then we also see the total expected vote and EVP, which is actually the same as the percentage of the votes in. So essentially, you'll see that there's kind of two main things here. There are the votes that have been cast, as well as the total expected votes, and the percent of the votes that have been cast. So you can see in this particular county, 4,251 votes have been cast. We have a total expected vote of 7,634. So what that means, we have 56% of people kind of reporting in. And what we really want to know, if you think back to that first question, in the case of Arizona, based off this percentage of people voting in, and based off kind of the winning percentages of each candidate, could you call Arizona a little earlier than expected? So what we're going to do here is then continue. Let me scroll down. I think you guys are at the very basics of the Coral Path. So let's see, live 28. I'm at live. I'm very far ahead of you, but oh well. Not much I can do in that case, I guess. Especially if you guys are then backing up further for the smoother streaming. So what we're going to do here is essentially start to focus on Arizona, just also make a quick plot of the results themselves. So what I would like to do is make a plot based off kind of blue versus red, who's winning the counties. And what we'll do here is the following. I'm going to say, if I take a look at presidential results, November 07, columns, there's actually 106 columns, so I'm going to say for call in prints call. So there's a couple of columns. I don't definitely need all of these, but I do want to know the county that these votes are happening in, the votes, And then I also want to know the percentage left. And, sorry, sound the phone. As well as the results for Trump and Biden. You'll notice it now has results for then other candidates, but we don't really care about those. We really just care about Trump versus Biden. So I want the results of Trump versus Biden having buffering issues. Does that fix it? Sorry, I just typed with someone if they're having buffering issues. All right, so I'm going to grab the columns that I actually care about. And what I'm going to do here is copy and paste them. So I don't care about all these columns. Instead, I'm going to grab a subset of these 106 columns. So I really care about the results for Trump, and results is just how many votes did Trump get in that county, how many results did Biden get, or how many votes did Biden get, total number of votes so far, total number of expected votes, and then EEVP, which is that percentage, right, of votes left. And if I just take a look at the head of that data frame, I get something that looks like this. So let's go ahead and say, for our particular case, pres underscore November 07 is equal to, whoops, November 07 is equal to this, except delete the head here. And I'm actually then going to call copy. And the reason I call copy is because sometimes you'll get a bunch of warnings saying, hey, you're editing a pointer to another data frame, and those warnings kind of annoy me, so I just say copy instead. Okay, so you run that, and we should now see November 7th has 3,159 rows, but now only 5 columns. So what I would like to see is a percentage based off which candidate is winning. So I can see how many votes, whoops, I forgot the FIPS as well. Sorry, let's add that back in. Whoops, we'll have to read in the data again, sorry. I also need the FIPS column. FIPS, comma. There we go. Okay, perfect. This is what I want. The geographical county, and then results Biden, Trump, total votes so far, total expected votes, and then percentage of votes that have come in, right? So what we're going to do here is we're essentially going to calculate some percentage of how much Trump is beating Biden by, or in theory, how much Biden is beating Trump by, and we can do that with just some very simple math. So I'm going to say president, or essentially our data frame, November 07. I'm going to say Trump underscore percent is equal to president 07, and it's going to be results of Trump divided by the number of votes total. So this is essentially calculating what percentage of the votes so far have been for Trump. And we'll say votes. And we're going to do the exact same thing now for Biden. We're going to say Biden, J. Using my stream. Okay, and now that we have the percentage that Trump is winning and the percentage that Biden is winning of the total votes, we want to calculate the Trump percentage over Biden. So we can do that by saying, and there's lots of different ratios you could calculate here, but we'll say Trump percent over Biden is equal to, and we'll go ahead and say pres November 07 of the Trump percentage that we just created minus the Biden percentage. So let's say pres. And obviously this may be positive or negative depending on who's winning what county. So we calculated the percentage of the votes, and then we want to see the percentage Trump is beating Biden by. It'll be negative if Biden is beating him. So if you run that, we should now be able to see President November 07, Trump percent over Biden, and it looks something like this. Perfect. That's exactly what we want. So we can see here Trump is beating by 0.14%, and over here Trump is losing by 0.9%, etc. So let's go ahead and plot out these results. I'm going to copy and paste some of the code that we already used up here, so I don't need to kind of rewrite it all again. So copy that, come back down, paste it, and my data frame is now going to be equal to President November 07. GeoCounties, JSON still the same, location is still the same, Mapbox still the same. The continuous scale, let me zoom out just a little bit here so I can see everything. Sorry, I'm zooming out on my other screen. Color is different. I would like to color this by this column, Trump percent over Biden. So let's go ahead and put that in. The color scale, we can actually do something really cool with Plotly, which is you just provide a list of 2 colors or even 3 colors, and it'll make a continuous color stream within those colors. So to do that, we can just do the following. I can say, close this off, and where's my notes? Color stream will be blue-red. Given the way I order the percentage, this should be the correct way to order these colors. Obviously, we want to associate red with the GOP and blue with the Democrats, just so things are kind of normal. And I think that should be it. The other thing we're going to add in is hover data. So as you hover over something, you can change what information is being displayed. So this is called hover name for what you want the main thing to display here. And we can see, we can choose maybe the name of the county or something like that. I think there has the name of the county here, ED1. Well, we can say the FIPS of the county as the name. So we'll say, go ahead and hover name the FIPS. And maybe what data we want over, we can say hover underscore data. It's just a list of data to display here. So what we're going to say is maybe we want the votes and EEVP or something like that. You can decide what columns you want to display and hover over. And whoops, make sure your columns are okay, or commas are okay. Range color, oh, we'll go ahead and comma that out. And I don't believe we should need range color anymore. So let's just comment out range color. Run that. And if you get stuck on this, go ahead and just copy and paste from the solutions notebook. Okay. So here we can see the percentage that Trump is winning over Biden. And you'll notice it actually looks kind of a lot more purplish. That's in effect of the range we're doing. But it should also tell you that actually in many counties, the election is kind of much closer. It's not just this kind of coastal cities versus Midwest or more rural areas. In fact, even in rural areas, the percentage he's winning by on November 7th is not a whole lot more than Biden. So even in places where you expect are extremely red, there's still quite a bit of Biden voters. Or the other way around, right? Even where Biden is winning quite a bit, there's still quite a bit of Trump voters. So like even these negatives are not that huge. So that's kind of an interesting, I guess, analysis of here. So essentially what that means is if somebody's voting for Trump, regardless of where they live in the United States, it's very likely that someone else in their community is voting for Biden. There's not a whole lot of communities in the United States where it's absolutely extreme for one candidate. There are actually quite a few votes for both. It's just depending on how you change this color scale, it could look really extreme. And also keep in mind, we're calculating like a percentage difference. So that's kind of another advantage to why this looks more purple. Okay, so let's go ahead and now focus on Arizona and see if we can make a little widget here. So I'm going to, like I said, you should probably be clearing these outputs. So cell current output clear. And then what we're going to do here is focus on Arizona. And what I would like to do is essentially calculate whether or not it was too early to call. And this would be for November 7th, whether or not it was too early to call that state. So what we're going to do here is check out the following. We do another analysis in a notebook for November 18th, but it's kind of the same thing. so you can see how things have changed. So focusing on Arizona, what I want is I want to figure out what are the Arizona states in Pres November 07th. So if I check out the head here, I have FIPS for all of the states, but what I would really like to see is just the Arizona ones. So I checked out this link that's also in the notebook, that's state FIPS code listing, and we're interested in Arizona, and you'll notice Arizona, if you zoom in, they all start with 04. So what I'm going to do then is the following. I will say pres underscore November 07, and here I can use string codes with pandas, along with starts with, which is a built-in Python string code. I'm going to say, where does this start with 04? Since I just looked that up, that the FIPS that start with 04 are the ones for Arizona. So we can run that. And whoops, data frame doesn't have that. Make sure I did this right. Oh, though I should be looking at the FIPS column, not the entire data frame. There we go. Okay, so now I have this booleans here, and if you do the sum of this, you'll notice that we have 15 counties. And luckily for us, there are 15 counties in Arizona, so that math is working out. And I'm actually only interested in these 15 counties. So let's go ahead and just only select these. So we'll do the following, something that looks like this. And now we have all the data just for Arizona. I have the results for Trump, results for Biden, votes, total expected votes, and then that percentage that's in. You'll notice this is much later on in the elections at November 07th. Some elections are almost basically at 100% votes in. You'll notice that total expected votes and votes won't ever match up exactly because this is a projection of how many votes are expected. You'll notice that in reality, either a couple of less people vote or a couple more people vote, depending on kind of what they're doing. And you should also note that in some of these, maybe it never really reaches 100% because just they didn't get the amount of expected votes. And you should also notice that for percentage, what was I going to say? Percentage, you should take also a look at the total expected votes because while only 4% of votes are expected in this particular county, you can see that there's a ton of people living in this county. So that could really make a difference, even if it's just a few percent left. So let's go ahead and let me make sure whether or not we have a county name here. That would be nice. So what I'm going to do is the following. I'm going to come back up here. Let's reread in that file again. Whoops, the original data frame, that is, this guy. Because I would like the name of the county, and I think that's a column we have available to us. So I'm just going to read in this guy again. And I'm going to select those columns again, like we did up here. The columns I'm quote-unquote interested in. So all I'm doing is I'm reading in the data again, and I'm going to add in, I think it's called name. That should have the name of the county. There we go. All right, so now we have the name of the Arizona counties, which would be nice just in case I want to play around with that value as well. Okay, and I think that's all I need. And now what we're going to do is switch gears a little bit from plotting stuff out on a choropleth map to actually having kind of an interactive display. And we can do this with IPyWidgets. You may need to install IPyWidgets, but essentially the main idea here is I would like to have a little slider that allows me to select what percentage of votes I think Trump or Biden's going to win that remain. So I can get some sort of total remaining votes expected, which would be this column minus the votes in, or this kind of 1 minus this percentage times this column. And then I could see, well, if Trump wins, let's say 80% of the incoming votes, will he win Arizona? Or if Biden wins 30% of the incoming votes, will he win Arizona? And it would be nice to have a little slider there that I can play around with, and then just hit a button and it would calculate it and give me the results. So to do this, we'll first learn a little bit of IPyWidgets. I'm essentially just copying and pasting from the documentation, so we won't dive too deep into it. This is more just to tell you kind of how I think about getting something done versus kind of fully understanding what's going on in the background. So I just Googled IPyWidgets, copied and pasted from the documentation, and that was enough for me to say, okay, I kind of get what I'm doing here. I just need a button click and then call one of my functions. So let's see what this looks like. If we take a look at IPyWidgets, I'm actually going to copy and paste this in here. So you can check out the IPyWidgets documentation. It's linked for you in the notebook. The first thing is you'll notice that there's this little click me button, which is kind of interesting. So that's something we're going to be using. It would be nice to have something that says, hey, click this, and it will display an output. And there's also, in the very simple widget introduction, there's this slider that will take in your value. So all I'm going to do is I'm going to copy and paste this from the documentation to see if I can connect a button and a slider, and then I'm pretty much done with what I need IPyWidgets for. Obviously, you can check out the documentation to get more complex versions of IPyWidget going. But we have our data set up. I'm going to kind of put that on hold. And now what I want to do is see if I can get a slider that will allow me to slide the input percentage that I want, and then we should be good to go. So just copying and pasting from the documentation, it tells me I need to import these things. So I say OK. And the slider itself, the way that works is you simply say widgets, integer slider, and you display W. Again, just copy and pasting for documentation, nothing too crazy here. And you'll notice that I can say these values, and by default, you'll notice if you check out the range here, the arguments are essentially the minimum value and the maximum value. And by default, they go from 0 to 100, which is actually the exact numbers I want, right? I want someone to be able to say, okay, I want Trump to win for 60% of the remaining votes in Arizona. Does he win the state if that happens? That's essentially what we're trying to do here. And it looks like that's working, but the question is, how do I actually grab this number? Well, what's kind of interesting here is they're connected. So if in another cell you say W value and run it, it'll report back the value. And if you change it again, call W value here, it updates. Okay, so that step is done. The next thing you have to do is check out the button example. So it's actually under widget events here. So I just looked at the documentation, I'm kind of scrolling around, I see this click me button, and then what I would like is just have something happen on this click me. So I'm going to copy and paste this code. Again, just trying to give you an idea of the way I think about these kind of things. Just like, okay, what's the kind of minimum viable product, so to speak, for this thing to work? So I just copy and paste this. If you run this, you click me, and it says button clicked. Perfect. What would be cool is if I could return back this W value. So let's go ahead and print, instead of button clicked, W value. Notice that it's actually calling this function here on click. So it says call on button clicked function, this guy, whenever you click the button. So now if I run this again, you have to rerun the cell to redefine that function. Click me, it's going to replay 14, and we don't actually know yet if I change it here, if it's going to affect it, and looks like it does. Perfect. And what would be nice if I could put these kind of in the same cell. So I'm going to copy this, paste it up here, rerun this, and now we're pretty much almost there, right? I can say select the percentage that I think the incumbent will win, click me, and it reports back 76, and clearly we can see now I just need to edit this function to do what I want, and it could bring out a big report saying, all right, if you want Trump to win 37% of the votes, click me for the analysis, and it will do some sort of analysis. Here, we're just reporting back the value, but we can do whatever we want inside this function. So now it's just a matter of figuring out this reporting function. And for that, we need to create a couple more columns, and then we're almost done. So what we need to do is calculate the actual total number of votes left. That is the raw number of votes left, not the percentage. So let's go ahead and take a look at the Arizona data frame again. I have this guy, which is my Arizona data frame. Let's just copy and paste this and assign it to Arizona. So I'm going to say Arizona pres November 07 is equal to this, and then I'm going to say dot copy. There we go. So I see Arizona pres November 7th is now this super nice data frame. I have results for Trump, results for Biden, votes, total expected votes. I would like to know the expected votes remaining. So that means the expected votes remaining. And you can imagine this is essentially what people like Fox News, Associated Press, New York Times, this is the math they're doing. They're essentially calculating the likely percentage based off previous results, and then calculating from there, but they're doing it at a county level. We're going to simplify this and do this at an entire state level. So just keep that in mind. So what are the expected votes remaining? That's pretty easy. It's just Arizona president November 7th. It's going to be total expected votes minus the current votes available. Pres and whoops, let's scroll over to the right here. Votes. Okay, so it's total expected votes minus votes so far is the expected votes remaining. So you run that, and now we should be able to see here, all the way on the right-hand side, this is how many votes we expect are remaining. However, you should notice something. Some of these are negative. And why are they negative? It's just because the total expected vote, that's always going to be an estimate, right? That's an estimate that the New York Times is putting out ahead of time. Like, we expect about this many people to vote. If it's negative, and you'll notice it's not negative by a whole lot on these counties, it's like less than 1%. It's like, and even though this might seem like a big chunk of negative, look how large this county is, right? It's over 1 million people, and they're only off by like 1,000, so that's not bad at all. So the thing is, I don't want these negative numbers to affect my results, because if you're at 100% and you're kind of over the limit, we're just going to say, you know what, there's probably no more real votes coming in from these counties anymore. So we'll say once you reach 100%, I'm not actually going to consider this anymore. So we need to kind of filter out the EEVP that is 100. So I'm going to say Arizona Press, and let's just grab it where EEVP is less than 100. So we run that. Notice we have a couple false, so we're going to filter that out. Let's get this guy. Okay, and now I can take the sum of this, and you should now be able to see how many votes are in play. Some of these sums don't make any sense. It's just, you know, all the FIPS added together. But what does make sense is these total expected votes left. So I have the total votes that Trump has, total votes that Biden has, votes so far, and we're kind of ignoring third-party candidates. We're going to say it's not going to make enough of a difference. Obviously, in real life, it does. So you would have to kind of have some sort of small percentage multiplier for things like Joe Jorgensen, the Libertarian Party, or other even like smaller candidates like the Green Party or Independents, or even write-ins. When it's super close, that could make a difference. And we have the total expected votes as well as expected votes remaining. So for the state, on November 7th, there's 181,000 votes remaining. And you'll notice that they're actually still quite close. So if we just take Trump and then give him, so Trump is technically losing on November 7th, but if he were to take 100% of the remaining votes, he would actually beat Biden. So then the question is, what is a reasonable percentage here for him to take? And that's where we're going to create that little report so that someone can actually choose with a slider what's a reasonable percentage or not. Obviously, you would probably want to do this at a county level, not a state level, but we can also see just what percentage of votes Trump has won so far, right? So I could say this number for results Trump divided by the votes so far. Run that, and you can see that Trump so far has won about 47% of the votes in Arizona. So obviously then you'd be interested in, well, what happens if he wins 47% of the remaining votes? And instead of having to rerun this math over and over again, let's create it as a reporting function. And that way we can report this every time, for a slider. And we click this like, oh, give me the report. So this should be fun, and we're kind of almost done here. So what we're going to do here is create a reporting function. I'm going to say DEF report, Trump percentage. So we'll label this in terms of Trump percentage. Like, you expect Trump to win X% of the remaining votes left. So let's check this out. I'm going to just print a little message for the user. Like, where are we? We're going to say, what's that F string? So you expect Trump to win, and we'll call this Trump percentage. Percent of remaining votes. So if you expect Trump to win that percent of remaining votes, that means, And remember this percentage is from the slider, so it's in terms of 0 to 100. So we're going to say Biden percentage is equal to 100 minus Trump percentage. We're assuming there's only going to be an even split between those two candidates. Obviously, if it's extremely close, you'll have to take into account third-party candidates. And we're doing this across an entire state level. You could make this reporting function with multiple sliders. What would be really cool is if you expand this project and say, this is the slider for this county, this is the slider for that county, etc., and start playing around with those results. Excuse me. Okay, so we have Biden percentage. And let's go ahead and calculate the final totals. So we'll say Trump final total would be equal to, and we can actually then just calculate this based off these sums right here. So I'm going to say vote sums is equal to this summation, because the only numbers I really need are the total for Biden, total for Trump, total votes remaining, and that's pretty much it. So I'm just going to call this votes sum and just grab it off of this series. Excuse me. And go ahead and make this a copy. So I have vote sums, just confirm what it looks like here. Okay, so vote sums, and then I can grab things like results Trump, and it gives me that number. So what we're going to be doing is, what's Trump's final total going to be equal to? Well, it's equal to vote sum results Trump D plus this percentage times the votes remaining, right? So it's going to be, let's see, that percentage is in terms of 1 or 0 to 100. So we're going to say 1 over 100 or times, just to get it in terms. So Trump percentage. You could also just say divide by 100 times the vote sums expected votes remaining. Expected votes, make sure we spell this right, votes remaining. I'm going to zoom out one level so you can see this whole thing here, or maybe 2 levels. So all I'm doing is I'm taking Trump's current numbers, which we can see here if we call vote sums. So just take his current numbers and then multiply it by your expected percentage of his win, and then multiply that by expected votes remaining. Since I don't want floating point votes, like, oh, he won 0.5 of a vote, we'll just cast this as an integer. Okay, so we have that ready to go. That's Trump's final total. We'll do the exact same thing, but for Biden. And to do this, we simply call this Biden final total. Results Biden J, and then Trump percentage will be Biden percentage, expected votes remaining. Okay, so then let's just report this out. We'll say print this would result with Trump having, and we'll just calculate the final total here. Trump final total, votes, print the exact same thing except now for Biden. Copy this, paste it in, and we're gonna get Biden's final total. Copy that, Biden having Biden final total votes. And let's just have a little if statement. So if Trump final total is less than Biden final total, we'll print Biden wins, else prints Trump wins. Well, wins Arizona, just to make that clear. So we have our little reporting mechanism. It takes in Trump percentage, which is a number between 0 and 1. So now let's put it together with what we have up here. I'm going to copy and paste this previous code. And now what do I need to change? So far, my widget's integer slider is okay. I really just need to change this DEF. So what this really should be is reporting the value. So we're just going to say report W value, because that's what this function is, right? It's report, takes in that W value, and then it's going to print a bunch of stuff depending on what's happening here. And then we'll have this be run report. So run that, and we should say, okay, I expect, let's say, Trump to win, I don't know, whatever percent you want here. Run report. And so it says, okay, you expect Trump to win 52% of remaining votes. This will result with Trump with this percentage, or this votes, Biden votes, etc. Biden wins Arizona, which is kind of interesting because if we saw before, Trump was only winning across the entire state, though, 47%. So that means if Trump just performs, and this is technically on November 7th, not November 3rd, and this is essentially the math that Fox News and other outlets are doing, right? They're doing this math, and they're doing it at a per county level. They're saying, okay, if performance continues as it has been, so if Trump's statewide performance continues across all the remaining counties, then you run this again, and clearly he's going to lose. So then you ask yourself, well, what percentage is he going to have to start winning in order to really actually win this? And even at 60%, Biden's still going to win this. Keep in mind, this is again November 7th. And you can see that he has to actually report really high. He has to get maybe like 71%. Maybe not yet. Let's push him to 73. Oh, wow. This is very close. 74. Damn. Almost there. 75. Boom. Okay. So on November 7th, Trump has to win 75% of the remaining votes to just barely squeak by a victory over Biden. And that's not even including third-party candidates. That's just 75% of everything that's left. So this is the math that they're doing on election night. And this is something that you can play around with. You can see if you can find a data set for election night and start playing around with these values. I would encourage you to make sliders per county. That would be really cool. And clearly there's a lot left you can start playing around with here. I'm going to ask you guys now, it looks like you're still quite behind on the stream, so I might just keep it running so it doesn't cut off. But yeah, if you have any questions, feel free to post them right now in the chat, and I will answer them. I'm going to put this on another screen so I can just tell. There it is. All right, let's see where you guys are at. All right, you guys are about, I don't know, 20 minutes behind? No, not